Hey guys, welcome back. So what we're looking at today is lesson 14, and that is surface area of right prisms. Surface area. So let's go ahead and jump right in. So here's a picture of a prism. So we have this crazy looking prism here. It's got this cross-shaped base, both top and bottom, and then it's got its rectangular sides. So 3 students are trying to calculate the surface area of this prism. Noah says this is going to be a lot of work. We have to find the areas of 14 different faces and add them up. Elena said it's not so bad. All 12 rectangles are identical copies, so we could find the area for one of them, multiply that by 12, and then add on the areas of the 2 bases. Andre says, wait, I see another way. Imagine unfolding the prism into a net. We can use one large rectangle instead of 12 smaller ones. So here are 3 different possible ways to take and find the surface area of this prism. So remember, surface area is when we cover the entire thing. So that includes top and bottom. It's covering all sides. So you could think about it in terms of painting it or wrapping it with wrapping paper, anything that helps you think about covering this thing. So surface area is always about covering. Normally when we talk about surface area, we talk about finding the area of all the faces and adding them together. Well, obviously in this case, that's going to be a lot of work. There's a lot of faces on this because obviously we have top and bottom. And then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12 faces, just like he says. And that there's 14 different faces. So we've got 14 different ones. 12 of them are the rectangles. Then we have the top and bottom. So lots to try and calculate in there. Now, the first question, do we agree with any of them? Explain. So, will any of their methods work? Yeah, they will. All of their methods will actually work for this. Sorry, had to get my pen up. So all of their methods will work for this. Now, even though all of them will work, some of them aren't going to be as efficient. Like Noah's, obviously his is going to take, and if he finds each of these rectangles individually, that's going to be really, really time consuming. We don't want to have to take and find all of them. Elena's is a little bit easier because she recognizes that each of these rectangles is 2 by 11. So that means all of them are 22. So we can just take 22 and multiply it by how many there are, and that gets us the area of all of those. So that's a little less work. Andres, now what Andres is talking about here is unfolding this. So if we take this all apart and stretch it out so that we have one big rectangle and then 2 plus signs, it's going to be even easier because then we just multiply our dimensions of our rectangle and then find the area of the 2 bases. So a little easier. It's more complicated because you have to figure out how to spread that net out and make sure that you get it the right size, but it is possible. For number 2, it's asking, how big is the one large rectangle Andre is talking about? So when we're talking about the one large rectangle, so, excuse me, I don't know why I'm yawning so much. We have this 11 by 2 rectangle. Now each of the sides are 11 by 2. And we established that there are 12 sides to this whole thing. So that means our large rectangle here is going to look something like this. And there's 2, 4, 6, 8, 10. Whoops, I don't know what I did there. 1, 2, 3, 4. Pretend that middle line isn't there. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Obviously, mine are not all the exact same size like they are supposed to be. But each of these lines, aside from this weird diagonal here, represents a fold line from up here. So if we were to have folded a piece of paper to form this shape, each one of our edges is represented by a line down here in this rectangle. Now, each of the sides was 2. So this is 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, and 2. So all of those were 2. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. So 2 times 12 is 22. So this side and the top side are 22. The height is still 11. So the area of this, or not 22, sorry, 24. Goodness. My brain is not working today, apparently. So 24. So 24 times 11 will be the area of our large rectangle. So that's what it's looking at there. Another way to have got that 24, the 24 is the perimeter of your base. So this equals perimeter of base. So that means we could take the perimeter of the base, multiply it by the height, and then we find what all those, the area of those sides, because we can spread this out. Now this works when we have prisms. It only works with prisms for this. So for 3, will Noah's method always work for finding surface area of prism? What about Elena's, Andres? So Noah's, no matter what, doesn't matter what we have, it will work for any prism. We can find all the areas of all the faces and add them together. That's always going to work. So Noah's, always. Elena's, now Elena's worked on this one because each of the sides of our figure were the same size. So Elena's won't always work. It'll only work when we have cases like this where all those sides are the same. And Andres will also always work because we can always take and spread this all out, find the perimeter, multiply by the height, then find the area of the 2 bases. Now, for number 4, which method do you prefer? That's for you to figure out. So play around with the different ways of taking and finding these, see which makes most sense to you, which one you find easiest and most comfortable to work with. Obviously, Noah's can be a lot more work in some cases. Now, Noah's may have to be the way you go in some problems because you can't use Elena's method. Elena's method definitely makes it a little easier, but that's also because of the shape we have that it is easier. Andres will always work, but you have to be able to see what it represents. So think about it in terms of, okay, what does this look like as a net? So what does it look like all unfolded? So it depends on how visual you are in thinking about this, okay? So what you guys are working on today is all about surface area. So surface area is about covering the figure up. So cover is your key word for this lesson, cover. If you guys have any questions, feel free to ask. Have a great day, guys.